All right, folks, we are finally done talking about Uranus. We are going to move forward now. And there we go. Next stop, Neptune. There it is. We call Neptune the windy planet. So, who can tell me the Greek equivalent of Neptune? Poseidon, yes. No, not Lucifer. Unfortunately for us, these Roman gods continue to boast pretty much of not having any clothes. And this is... At least he's not super old like the other guys, right? When I made this, it reminded me of an Abercrombie & Fitch ad. I find it interesting that they're a clothing store and the people in their ads wear like nothing. Go ahead and write down, do the first 2 bullet points here. So a little bit about the quote-unquote surface on Neptune. Again, this is the sort of thing where we don't have a solid surface. Neptune is an ice giant. You can put that bullet point in. Just the one, though. It is also a gas planet, but because it's so much further away from the sun, it is much colder, and so they refer to it as an ice giant instead of just a gas giant. Just the first bullet point. Everything else here should sound the exact same as the last 3 planets. For the last 3, there's no solid surface. Pressure rises as we descend, so if you picture yourself falling through Neptune, it would be like falling through clouds that get thicker and thicker and thicker, and eventually you get to a point where they're dense enough where you're not really falling through air anymore. It's kind of turned into a liquid, and that's what you would experience as you descend. The pressure would also get much larger. So this is just a little picture of the cloud tops of Neptune. That's a pretty good description of how big the sun is going to be from this distance. Voyager 2 is actually the only spacecraft that visited Neptune. If you type in what the surface of Neptune might look like on Google Images, this is the sort of thing you'll see. This isn't quite right. You're not really going to have big solid surfaces at this point. You'd have to be down quite a ways, and you'd be down far enough that you probably wouldn't be able to see anything from the sunlight coming through. So there could be solid surfaces, there could be water down there somewhere, but it would be totally dark by the time you reach that depth. In terms of the clouds, we've got methane, but not as much as in Uranus. You can go ahead and write down the top bullet point there. Do the second bullet point too. It's a nice little comparison. Now, Neptune is much further away from the sun than Uranus is, and eventually we're going to get to the point where we're going to do a little experiment where I'm going to show you comparatively how far these planets are away from each other. But basically, as you get further out in the solar system, the bigger those distances are from each other. So Neptune is much further away from the sun, and yet it has cloud tops that are warmer than the cloud tops on Uranus. And the reason for that is because Neptune has extra hydrocarbons. And hydrocarbons, of course, are what make the greenhouse effect work. So the top of Neptune is actually warmer, despite the fact that it's so much further away. You can still see some of those nice little swirls here. That's kind of neat. You can skip this whole thing. This is all the same as with Uranus. The methane in the clouds of Neptune absorb all of the red colors from the spectrum, so what's left is it reflects back all the bluish colors, and that's why Neptune looks blue to us. This is all the same too. You can skip it. You would sink down into Neptune's surface. It's made up mostly of hydrogen, but it also contains water, ammonia, and methane, all the same as what we've seen. Go ahead and write down Voyager 2 in 1989. That is the only time we had an up-close view of Neptune. Just the title, yep. And if you remember, when we visited Uranus, what ended up happening is when we got there, everything was just kind of plain. It was a bluish, sphere without really any clouds, without any features. Neptune was much different. When the Voyager 2 spacecraft flew by, you could see these white clouds. If you look real close, you can see kind of a darkish band right there and kind of another dark spot in that location. So it did look different from Uranus. Another picture there. That's what Voyager 2 looked like. This is not an actual picture of it. If you look close here, you can actually see there's a little ring that goes around Neptune that we'll talk about later. Write this down. The white cloud bands you see indicate very, very high winds. Does anybody... Oh, I'll let you write it down. The wind speeds associated with these big white clouds here, these clouds that look very, unintimidating. They kind of look like those cirrus clouds that we see, those wispy clouds way up in the atmosphere. They are anything other than that. Anybody remember the fastest winds that we've seen so far? Higher than 750? Yeah. It was like 1,000, or a little bit higher than 1,000 even, I think. Yeah, those were on Saturn, and so that's going to be a wind speed that we're going to try and beat here on Neptune. We're going to see if we do that. So the Great Dark Spot, this is one of the most prominent features on Neptune. Go ahead and just write down Great Dark Spot. It was interesting. People actually got worried that this spot had disappeared because for a while it just seemed to go away. It has since reappeared, though. So the Great Dark Spot kind of comes and goes. But just like the big red spot on Jupiter, it's a gigantic hurricane. Here's a close-up view. And notice that associated with the big dark spot is these white cloud bands. And that's actually the location of the highest wind speeds on Neptune. And those highest wind speeds get up to a blazing 1,500 miles per hour. That is Mach 2, folks. Twice the speed of sound is what we have sustained wind speeds at here on Neptune. Go ahead and write down the second bullet point and the third bullet point.
Second and third?
Yep. So yeah, 1,500 miles an hour. You can probably guess what your fate is going to be if you step out the spacecraft. We'll get to that in a little while. But yeah, 1,500 miles an hour, you're booking it. And it's not like this is just a gust. We're talking sustained wind speeds this fast. And that dark spot is about the same size as Earth. So Earth is about that big, for reference. This is the windiest planet in the solar system, max wind speed 1,500 there. You can see this little white cloud band, Scooter, they named it for some reason. But little Scooter goes around the entire planet in just 16 hours. And if you just kind of think about a weather system moving that quickly. I remember when I was a kid, my cousins lived in Pennsylvania. And, of course, weather systems move from west to east. And it was always kind of interesting. It always seemed like the weather that we got in Wisconsin made its way over to Pennsylvania after about 3 days. So it takes about 3 days for a weather system to cover half of the United States. Imagine a weather system that just takes half a day to go around the entire world. And that's not even to scale. I mean, with as fast as this thing is moving, it would take maybe 15 minutes to go from here to Pennsylvania. That's how fast that band of clouds is moving around Neptune. Because Neptune is much larger than the Earth. Very thick atmosphere here. No, you can skip this one. Probably recognize this picture. Yeah. When you type in thick atmosphere to Google Images, you don't get a whole lot of different things. So there's Neptune, and when the Voyager spacecraft went by, once again, you can kind of see that we have these very thin lines here. If you were standing in this location, you would not see them. In order to see them, just like with Jupiter, just like with Uranus, the Voyager spacecraft could not pick these up until it had passed by Neptune, and it was actually in the shadow of Neptune there, looking backwards. And so that's when we were actually able to pick up these actual images of the rings of Neptune. A little bit about these rings. They're super faint. You're not going to see them till you're right on top of them. Write down the second bullet point. And so this is in contrast to the material that makes up the rings of Uranus. The stuff that makes up those rings is much larger. You're talking 1 foot across to about 60 feet across. But on Neptune, it's just very, very small bits of space dust. So it's kind of interesting how these rings are made of completely different pieces of material. There are those rings. This is an enhanced image there. They don't look like this. They would not look like this if you were in this position. But if you want to see exactly where they are, you can see their locations there. 3.9 times the size of Earth. You could fit 57 Earths into Neptune. And in terms of its average density, 1.64. So it's, still very sparse compared with the terrestrial planets that you can walk on, like Mercury and Earth and Venus. And it's also much more dense than places like Saturn. But if you stuck Neptune in a big bathtub of water, it would sink. Because to float, this would have to be less than 1. In terms of measurements here, write down that it's, if you don't know, it is the 8th planet from the Sun. You can write that down if you're not aware. Also do the distance here. 30 astronomical units away. Anybody remember how far away Uranus was? Yeah, tell me, because I don't remember actually. That's why I'm asking.
You made us write that down?
I don't actually know. I don't think I had you write it down. Okay, I don't remember off the top of my head. But Neptune is much further away. So now you are 30 Earth to Sun distances away from the Sun. So you're really, really out there. Go ahead and write down the first bullet point here. 16 hours to go around once. How long does it take Scooter to go around Neptune? 16 hours. So I actually don't know what direction Scooter is going, if it's going with the rotation or if it's going against it. But if it's going against the rotation, then Scooter would look like it's stationary as Neptune spins because it's moving as fast as it's spinning. Kind of an interesting little fact there. Temperature on Neptune, it's cold on those cloud tops. You can write this down. Yep. So again, 0.1 bar, that would be the cloud tops of Neptune. Any guesses on what the temperature is at the quote-unquote surface, where the pressure is the same there as it is here?
The same.
Not quite the same. Negative 340 is pretty close. Negative 330. You can write this one down too. You guys heard about those sand dunes that, like, sounds like they sing when you make a little sand avalanche? You guys heard of that? Caitlin has. Anybody else? It's really interesting. That just made me think of that. I don't remember where I saw that. But if you YouTube singing sand dunes, I bet you'd see it. It's really interesting. So the information that we're going to be talking about is on your handout now. Neptune has a magnetic field. And Neptune's magnetic field is kind of the same as the one on Uranus. In the same way that, on Earth, you could represent our magnetic field with a big magnet going right down the middle. But remember, on Uranus, it was a little bit different. That magnet would be off to the side a little ways. And Neptune is the same. If you would represent the magnetic field on Neptune with a bar magnet, it would be positioned very off-center. And this... I heard something. Whose is this? Yeah. So, in terms of the magnetic field here, go ahead and put a little arrow next to the third bullet point. That should seem very familiar. Same story as the magnetic field on Uranus. It's generated at shallow depths within the planet's water ammonia ocean. Nobody really knows what makes it that way, but it is there. And this is kind of a cute little diagram. You've got Uranus on the left, and you've got Neptune on the right, and kind of looks like a big bug, doesn't it? With the eyes. Anyway, I'll give it a smile. That works a little bit. But you can see how the... Yes? Yeah, I'll get you a pass. Just have to fill this out the rest of the way. October 15th and 1 o'clock. So you can see how the bar magnets are aligned here for Neptune and Uranus. And it's kind of interesting how they're both completely off-center. And it'll be interesting one day to figure out exactly why that is and what produces these magnetic fields. Perhaps. Maybe it's a dark magnet that's producing the magnetic field. So in terms of water and ice, we've got to talk about this because one of the reasons that they named Neptune Neptune is on account of all the water. And you can see that we have on the bottom here, water oceans might actually exist inside Neptune. So go ahead and write down that very last bullet point. Actually, Neptune was discovered before we actually knew anything about it, so I take that back. They didn't call Neptune Neptune because there was water in it. It was named before we got there. But it is kind of an interesting coincidence that Neptune would have all this water. And it exists throughout the planet in vapor form. It's not a real prominent thing, but as you go down, you get more and more water and less hydrogen, just like on Uranus. He came back and what?
He came back because they were renamed because the house was named beforehand.
Probably.
Probably named just because it was blue.
That
They
could
were like, well, we've gone with these ones. Like, why not?
that could be it, yeah. Who knows? In terms of the composition here, you're talking about basically the same thing as Uranus. You got the gas on the outside, turns into liquid on the inside, and you have a solid core. The main difference, and what you should write down from this slide, is that last bullet point. It's just like Uranus, only it has more water. I'm going to use water as a little tangent here. Anybody know what my favorite shark is?
A hammerhead?
Nope, nope, nope,
Tiger?
nope,
Nurse.
nope,
Bull?
nope,
White.
nope.
Thrasher.
Whale?
Mako, yeah, was that you, Tyler? Nice, yeah. Mako shark is my favorite shark. It's the fastest shark out there. They can jump awfully high in the water, and that's what that is right there. So in terms of gravity here, you're going to feel a little bit heavier on Neptune. Neptune has a little bit more material than the Earth does. Of course, it's spread out over a large area. But yeah, you'll feel a little bit heavier. In terms of your jump height then, you're going to want to write this one down. Do, wait a minute, no. Write down this one, sorry. Do both of those bullet points. What happens if a fish gets COVID? Maybe it would make them fly. Wouldn't that? So now sharks can fly. That's the real results of COVID-19.
It's soulless.
So,
That was the most random question I've ever
if there is one thing about this class, it's probably the randomness that comes out of my mouth. I was just thinking of shark, and I was like, sharks are flying. What happens? Maybe COVID would have that effect on sharks. Who knows?
Are we writing this?
No, you're not writing this. But yeah, you would have a jump height a little bit less than Earth. Yes.
Thrasher sharks are the
What's that?
Thrasher sharks.
Oh, thresher sharks. Yeah,
They're so cute.
they are adorable. They got the cute little mouths and the.
Stupid. And they have really little tails.
They do. They do. I picture thresher sharks as just being like dum-de 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 dum. Like when you see a thresher shark face, that's what it looks like it's doing all the time. No, impossible. Your homework is to look up the face of a thresher shark and tell me that they're not adorable.
Goblin sharks are the most adorable.
Oh gosh, that's the ugliest thing in the world.
They're not. They have beautiful
So if the sun looks, yeah, take a couple seconds, find a thresher shark and.
Ah! Don't look up goblin shark.
Yeah, they're ugly.
PSA, do not look up goblin shark. Oh my god.
I'm sure the folks at home are loving this. Okay, back to reality.
Let me see what a goblin shark looks like.
The sun looks this size from the Earth. From Neptune, the sun is going to look much, much smaller.
God dang. But it's still gonna hurt your eyes, right?
Yes, it would still hurt your eyes. You can only see Neptune at night. Unfortunately, though, It is too dark to be seen even on the clearest, darkest nights without a telescope. You do need a telescope in order to see Neptune. If you have one, like the one I have, this is what it would look like. Just kind of a small disk. You're not going to see any features. You're not going to see the dark spot. No.
Go right down.
Nope, I'll let you know what to write down. You can write down this one. If you're hanging out near the cloud tops on Neptune, this is what you would see. It would look sky blue during the day.
That looks like something for you.
Yes, that's what I'm saying. Thank you.
Somehow wound up with my stuff.
Okay, thanks. So write this whole slide down. And this is really close to what you would see. Would you guess that we are in a windy area or a calm area of Neptune? Windy. How do you know that? Yep, because of the clouds. You can see those white cloud bands. That's always indicative of these high winds. In the distance, you can see this right here. This is one of the bigger moons of Neptune. Neptune's really only got one moon worth talking about, but that won't stop us from looking at 4 different ones. But this is the main one, and this is called Triton. More about that tomorrow. Interesting picture here. This is what a sunset looks like on Neptune. As the sun sets, you've got darker and darker shades of blue until it just fades to blackness. So, what do you suppose is going to happen to our sacrificial freshmen?
Yes, they don't exist anymore. They just
Yeah, basically, the wind is going to destroy you before you can even be conscious of the fact that there's wind. So you can write this one down too. Well, if you were in like, okay, here's another tangent. Speaking of that, you guys probably never seen the old American Gladiator show. They had an event on there called Powerball where people were in these gigantic metal balls and they had to try and get to certain locations before the gladiators got to them. And if you were in one of those balls, what would end up happening is you wouldn't get shattered by the wind, but the wind is going to take that ball and throw it extremely quickly. So you would die from a collision within your little bubble. Soft bubble? It'd have to be pretty soft. But anything's possible, I guess. Death by wind. Go ahead and do this one as well. So when I say old here, I'm referring to billions and millions of years. So Neptune is giving off heat. And it's giving off way more than it's receiving. If Neptune was the result of gas clouds condensing over billions of years, that heat would have long since been gone. It would not still be giving off all that heat. It would just be giving off what it's reflecting from the sun. But that's not the case, and that's another example of our solar system being young compared to the billions of years old story. A couple other small fun facts about Neptune. It is warmer than Uranus, despite being much further away. The smallest of the 4 gas giant planets. It also has surface gravity that's almost Earth-like, because if you're actually on the surface of Neptune, if it was somehow solid, you'd feel about the same as you would on Earth. And it's only been visited by the Voyager 2 in 1989. We haven't been back since. Awards time! Write this down. That's a pretty cool category to come in first place for. Neptune has the highest winds in the entire solar system. And just for reference, you don't have to write any of these down, but second place, Neptune comes in for the smallest orbital speed. It's traveling slower in its orbit than almost all the other planets. Second longest year, second furthest from the sun, second least eccentric orbit. So there you go. Quiz on Neptune coming up when you come back on Monday. Watch out for those flying sharks.